All right, ladies and gentlemen, we are jumping into Chapter 8. Chapter 8 is all about right triangles. Okay? Every single thing we do in Chapter 8 will have a right triangle in it. And you can see that right at the bottom of your page there, correct? If you flip it over, you'll also see lots and lots of right triangles. Okay, now, there was a reason we did radicals to begin with, because we're going to need to use them all the way throughout Chapter 8. Okay, so that's why we kind of stopped and did those radicals first. We also are going to have to know how to solve proportions in Chapter 8. These are proportions. Do you see how you have a fraction equal to a fraction? That's what a proportion is. You know how to solve these, I think. How do I solve these? Oh, somebody earned a gold star today. How do I solve these? That is one way to do it. It's the hard way to do it. So I can do it that way by get rid of the denominators, but I don't think you want to. Do you believe me? Isolate the variable, always the way we solve an equation, but how am I going to get there to isolate the variable? Cross multiply. You guys remember cross multiplying? Yeah. All right. Gold star for the day, sir. All right, so let's cross multiply. What is n times 8? And what is 12 times 3? All right, so how's everybody doing with my setup there? Good. Now, just as Nate said, isolate the variable. What do you do? And what do you get? N is, it's going to be a decimal. Don't be surprised. 4.5. All right, 1 down, 3 to go. Let's take a look at the next one. Again, you have a proportion, a fraction equal to a fraction. So we're going to cross multiply. Now, folks, does everybody see how this thing right here is a binomial? You see how there's two terms up there, correct? So when I cross multiply, I have to distribute the 4 to that binomial. So I would write it like this if I were you. Does that make sense? Yes? Now, what's the other diagonal? What's 12 times 3 again? All right, how are you going to solve this? Distribute. Okay, now isolate your variable. And what's x, folks? 5. If you need me to pump my brakes here on this isolating, you just let me know. I have no problem doing that, but I also don't want to bore you, okay? All right, over here, same idea. Does everybody notice how both of these things are binomials? So they're both going to have to go in parentheses and have the other term distributed to them. If you don't, you're going to be really incredibly sorry because it's not going to work out the way it should. All right, so let's distribute. What is 10 times 8j? Okay, how about 10 times 14? I just taught my daughter the trick on multiplying tens, right, where you just add a 0 to the end. She's in 3rd grade. They're working on their multiplication. She thought it was the coolest thing ever. I was like, oh, honey, you got a lot to learn. 30 times 6. And those are j's. And then 30 times 2, of course, is 60. Now remember, if I've got variables on both sides, I'm going to move the smaller one over. You don't have to move the smaller one. It's just what I do. Okay, if you want to move the bigger one, more power to you. So now I have 140 is equal to 100j plus 60. I'll get rid of that 60. And I have 100j is equal to, what is that, 80? And how do you solve that? Divide by 100. And don't be flipping out on me. What's j? 0.8. Can you turn that into a fraction for me? 4 over 5. Either of those answers would be totally acceptable. All right, last one over here. Let's go ahead and distribute. I've got the 50 that's going to be distributed. And I've got the 15. Oh, if I can fit it in here. That's got to be distributed. All right, what is 50 times 6m? And those are m's. How about 50 times negative 12? Say it again. Okay, 15 times 15, we know that one. It's a perfect square, right? 225. And then another 15 times 15 is another 225. Okay, I'm going to move my smaller m over. In that case, it would be minus 225m. And I apologize that I definitely ran out of room here. So I have, what is that, 75m minus 600 is equal to 225. Can you guys follow through my chicken scratch here? Yeah? All right, now isolate, move the 600 over. Makes 825. Divide by the 75. What do you get for m? 11? 1, 1? All right, does everybody remember how to solve proportions? Yes? Okay, so we're going to talk about the geometric mean today. You can kind of see that up here on the top of your sheet, the geometric mean. You learned about the arithmetic mean back in probably 6th grade with Mr. Contact. Do you know what mean is? It is the average, okay? Oops, I don't want a highlighter. Sorry about that. And how do you find the average? Perfect. You add, then divide by how many there are, right? You guys have been finding averages for a long time. Progress book takes the average of your grades, right? Okay. Total number of points divided by however many points there were. Unless your teacher, like me, does weighted grades. For me, I say 25% of your grade is your homework and 75% of your grade is your tests and quizzes. Okay. So it's a little bit different. So we're going to talk about a geometric mean today. Okay, geometric mean. And of course, geometry likes to be difficult, right? So it's going to be different. But don't worry, we'll work through it. Here's your definition. It is the positive square root of a product. The positive square root of a product. Now, you know from our work with radicals, if I take the square root of a variable, I have to put a plus or minus in front of it, don't I? But this is telling you don't do a plus or minus. I only want the positive version. Because if I deal with right triangles, do I want a side that's negative 10? No, in a triangle, I cannot have a side that's negative. So hence, we're specifying it's always the positive square root of a product. So here's what it looks like. That is a proportion that you just solved in your warm-up. So if you are going to cross multiply this, what's a times b? What's x times x? X squared. And how would you isolate for x? You'd take the square root. And I would have the square root of AB is equal to x. Notice I did not put a plus or minus on it. I want the positive version of that. Okay. Do you see how I'm talking about the positive square root of their product? Does everybody see that? You see the product there, right? The multiplication? And I took the square root of it. Agreed? Okay. Now, I need you to pay attention to these 4 spots here in this proportion. These things right here, those are your geometric means. Do you notice how the x goes in 2 spots? That's on purpose. Okay, and then the other 2 numbers are called your extremes. Okay, so we have the means and the extremes. Okay, the means are the important ones. All right, so I have this triangle. Now, I'm sorry, I'm not going to go to the triangle yet. We're going to do a couple of these practice. So it says, find the geometric mean between each pair of numbers. Now, folks, back here, I highlighted in green where the geometric mean goes, correct? Do I know the geometric mean of these numbers? No, that's what I'm trying to find. So I'm going to say, okay. Those are my geometric means. Those are the spots they go in, correct? Aren't those the spots that I had highlighted in green on the last slide? Yup. And then we put the extremes in the other two slots. Now, I apologize, that's a little crooked there, but you get the idea, right? So how am I going to solve for x? Cross multiply. What is 2 times 50? What is x times x? So how would I solve for x? Take the square root. And normally, you would say plus or minus, correct? But you're not going to here, are you? Nope. What is the square root of 100? 10. That's your geometric mean between those two numbers. Can you guys see that 10 is not exactly between 2 and 50, right? That would be the arithmetic mean if it would be directly in the middle. This is the geometric mean, which is definitely different. All right, let's try number 2. I want to find the geometric mean of this. So I'm going to put my x's in the spots where the geometric mean goes. And then I'm going to say my extremes go in the other two spots. Now, folks, can I stop here and ask you for your eyes, please? Would it matter if I wrote it like this or like that? Does it make a difference? Would it make a difference if I switched the 4 and the 36? No. So please understand, as long as you have them diagonal, we're good. All right, cross multiply. What is 36 times 4? 144 is equal to, what's x times x? Wonderful. How do I solve for x? And again, normally you would put a plus or minus on this, but we're not because this is the geometric mean. What is the square root of 144? That is my geometric mean. All right, I'm 2 in and I got 2 to go. How we doing? Pretty good? All right, let's take a look at number 3. I want to find the geometric mean. So I put the x's diagonal of each other. Then I put my extremes in the other two spots. What is 15 times 40? And x times x. To solve, we'll take the square root of 600. And I ask you, what is the square root of 600? Yuck, right? Gross. It's irrational, isn't it? So you're going to use what you know about perfect squares to simplify this, because of course I'm going to be difficult and I don't want the decimal. So what can you find within 600? 100 times what? Wonderful. And which one of those comes out? The 100. And what does the 100 come out as? A 10. And what's left underneath? Wonderful, folks. That's the type of answer that I'm looking for. And now you see why we did all that work with radicals, right? Okay, let's find one more geometric mean. So I'm going to put those x's diagonal of each other. And I'm going to put my extremes in the other two spots. What is 12 times 15? And what is x times x? So we're going to take the square root of 180, and it's not a perfect square. It's irrational. So I ask you, what can I find within 180? 36 times what, sir? Wonderful. And which one of those comes out? The 36, and it comes out as a 6, and the 5 is left underneath. All right. Now I promised you right triangles, didn't I? Yes. So we're going to deal with some right triangles. Now, I'm going to show you this next slide, and I don't want you to freak out. Okay? Lots of stuff going on here. What I need you, don't write this. Don't write any of it, please. What I need you to do is I need you to look at this triangle up here. Okay? How many right triangles are within this picture? There are 3 triangles in this picture. You have the big one on the outside with this right angle. Do you see that? You also have the 2 little ones that are within there, don't you? Do you see how there's 3 triangles in this picture? Okay, the other thing I need to talk to you about is, what is a hypotenuse? The biggest side, and it's always across from The right angle. So what is the hypotenuse of the big triangle? A to B, right? Does everybody see that? You guys see this right angle up here, don't you? So the side across from it, which would be this side, I see why you said point D, because point D is across from that, but the side would be from A to B, wouldn't it? Does that make sense to everybody? Do you see this little triangle on the left? The right angle would be down here, wouldn't it? What would be the hypotenuse of that triangle? Little b, which is AC. Yep. And if I look over here on the right, my right angle would be there. Where would that hypotenuse be? A little a, right? Which is CB. Agreed? Okay, so that's really what I need you to get out of this. You know what the hypotenuse is, correct? What are the other two sides called? What legs. There we go. We're going to get opposite adjacent when we talk about trigonometry. So if you do, really what I would love for you to do here is not write any of this. If you would just draw me a triangle here and just label that this is a leg, this is a leg, and this is the hypotenuse. That is really what I need. I can get you to the rest of it. Now, I'm going to tell you that you might be a little bit confused in the next few minutes. But I'm also going to tell you that we're going to spend 2 days on this. And we all know that everything gets better after the second day, right? So just bear with me and ask me the questions that you have. Are you ready? Okay, here we go. The altitude. Guys, what is altitude a fancy name for? The height. Okay. So the height is the geometric mean between the segments of the big hypotenuse. The segments of the big hypotenuse. All right, so let's take a look at number 1 for me. What is the height of this big triangle? If it was actually laying flat, what would be the height from top to bottom of the big triangle? KM. Does everybody see KM? And that would be the height. Agreed? That is E, correct? So from what I just wrote up there, E would be the geometric mean between the segments of the big hypotenuse. Now, what is the big hypotenuse here? Correct. And what is that? From what letter to what letter? Does everybody agree that that would be the big hypotenuse? What are the segments of that big hypotenuse? And what numbers would those be? So that would be the geometric mean that I can set up. The height is the geometric mean between the two pieces. How are we doing on that? Height is the altitude, correct? Yes? It is the geometric mean, so it goes in those two diagonal spots of the two pieces of the big hypotenuse. Those go in the other diagonal. So how would you solve this? Okay, so I would have 6 times 24, which is what? Is equal to E squared. How do I solve for E, guys? Square root it. And what is the square root of 144? Wonderful. That's E. Okay, let's go to number 2. What is the altitude or the height of this big triangle? Z. Would you agree if this thing was laying flat on that side, Z would be from the tip top all the way down to the base? Yes? Okay, well that has to be the geometric mean between the two segments of the big hypotenuse. What are the two segments of the big hypotenuse? 8 and 25. So those go in the other two spots. Are you picking up what I'm laying down so far? Yes? Okay, how would you solve this? Okay, what is 8 times 25? 200 is equal to z squared. How do you isolate for z? Square root it. Now, 200 is not a perfect square, but what can you find perfect within 200? This is 100 times 2. What does the 100 come out as? A 10. And what's left underneath? The 2. So that would be z. Fair enough? All right, let's see what else I got here. All right, let's take a look at number 3. Can you tell me what the altitude of the big triangle is? 12. From here to here, that's the altitude. So that's the geometric mean. That has to go in the two diagonal spots. A little bit different than the last ones we just did. Now, what are the segments of the big hypotenuse? X and 9. Can I now solve for x? Sure I can. Cross multiply, what is x times 9? And 12 times 12. And how do you isolate there? So what's x? All right. We're moving and grooving now. Let's keep going. Number 4. What is the altitude of the biggest triangle? So that has to be the geometric mean between the two pieces of the biggest hypotenuse. What would those two pieces be? Wonderful. Please don't be scared off by that t plus 1. If I'm going to solve this, the t plus 1 is a binomial. So you have to make sure you distribute the 24 to it. Everybody doing okay? Yeah? All right, so this will be 24t plus 24 equals 144. Can somebody subtract that 24 over for me? So 24t equals 120. Now divide by the 24, and you get 5. All right, and let's go over to number 6 here. We're skipping over 5 and going over to 6. All right, what is my altitude of the biggest triangle? So that is the geometric mean between the two pieces of the biggest hypotenuse. What are those two pieces? Do you understand why we're saying 4 here? Because if the whole thing is 6, that means this piece has to be 4, right? Are we making sense? All right. Cross multiply, I get 8 equals y squared. Take the square root. Is 8 a perfect square? No. What is perfect within 8, though? So this is 4 times 2. What does the 4 come out as? And what's left underneath? Wonderful. I think we're pretty good on altitudes, don't you? All right, let's go to the legs now. Okay, so I'm going to go all the way back up to the top. And it says the length of a leg is the geometric mean between the whole hypotenuse and its adjacent segment. And its adjacent segment. Now, we mentioned that word adjacent earlier. Okay, adjacent means next to. We've talked about this before. I've said that Mrs. Russell's room is adjacent to mine, correct? My room is adjacent to the bathroom, right? It's next to the bathroom. So let's take a look at what that looks like. Now, everybody take a look at this big triangle here. You see it? Yes? Name me a leg. C is one of those legs. Would you agree? So the leg is the geometric mean between the whole hypotenuse. How big is this whole hypotenuse? 30. So that's one of my extremes, and it's adjacent segment. Now, folks, here's the C, correct? The segment adjacent to it is the segment that's next to it. How big is that segment? 24. So there's my setup. And now we're off to the races, right? Cross multiply. What's 30 times 24? So c squared is equal to 720, and of course you could have that flip-flop. 720 is equal to c squared. Take the square root. I don't think 720 is perfect. So what can you find me that is perfect within 720? 36 and 20. The 36 comes out as a 6, and the 20 stays underneath, correct? But there's still something perfect in 20. Wonderful. What comes out of the 4 times the 6 that's already out there makes 12, and the 5 is left underneath. You could have done that in one step if you saw that there was a 144 in there. How we doing? But folks, that's only one of the legs, isn't it? What's the other leg in this big triangle? D is the other leg. So that is the geometric mean between the whole hypotenuse, and how big is the whole hypotenuse again? 30, and its adjacent segment. So adjacent means next to 6. How's the setup? Okay, cross multiply. 30 times 6, I believe, is 180, is equal to d squared. Take the square root. 180 is not perfect. What is perfect within 180? 36 and 5. And the 36 comes out as a 6, and the 5 is left underneath. And ladies and gentlemen, we've now found all 3 variables that were in that original picture. Does that make sense? We started with the altitude, didn't we? And then we went to the legs. I would always suggest, if you can, to start with the altitude. All right, let's try another one over here. Can you tell me what one of the legs are in this big triangle? X is one of those legs. So it is the geometric mean between the whole hypotenuse. How big is the whole hypotenuse? The whole thing is 33. And the adjacent segment, adjacent means next to, that would be my 8. All right, well, I want to stop here. How am I doing? Are you staying with me? Yeah? Hopefully the repetition will help. Okay, that's what I'm after here. What is 33 times 8? So I have x squared is equal to 264. I'm positive 264 is not perfect. What can you find me within 264? If you're not sure, go back and look what was multiplied together. What could you find me within either of those two numbers? A 4, right? So 4 times what? Wonderful. The 4 comes out as a 2, and the 66 is left underneath. All right, let's do the other leg now. What's the other leg of this triangle? Y. So y is the geometric mean between the whole hypotenuse, which was how big, and the adjacent segment, which is what? 25. Wonderful. All right, so what is 33 times 25? 825 needs to be taken the square root of. Now, folks, look at what was just multiplied together. What are you going to find perfect in 825? Yeah, this is 25 times 33. And what does the 25 come out as? A 5. And what's left underneath? The 33. All right, here we go with number 3. Which leg would you like to start with? Z, I hear. Okay, so Z is the geometric mean between the whole hypotenuse. Now, folks, I was missing the x, wasn't I? Did we find x already? Yeah, it was 16. We found that with the altitude. So what's the whole hypotenuse? The whole thing is 25. And then what's the adjacent segment? The 9. All right, 25 times 9. Ooh, I like that 225 number because it's perfect. What's the square root of 225? Wonderful. All right, I got one more leg in this triangle. What is the other leg in this triangle? Y. So y is the geometric mean between the whole hypotenuse, which is how big, and the adjacent piece, which is how big. Wonderful. We're moving and grooving now. I'm feeling good. Is that replicating how you're feeling? Are we doing okay? Yes? Okay. 25 times 16 is... So y squared is equal to 400. Loving that number too, because what's the square root of 400? 20. 20. Now, folks, in this diagram, did I put an X and a Y in there for you? I did not. Can you please, where do I want to put an X? Let's put an X here and a Y here. All right, which leg would you like to start with? I'm running out of time. X. So X is the geometric mean between the whole hypotenuse. Now, folks, I found out what T is, don't I? So how big is this piece over here? That's 6. So the whole hypotenuse then is 30. Everybody see that okay? And what's the adjacent segment to that X? 24. I think I'm going to have to stop here, but I do want to at least set up this Y. Y is the geometric mean between the whole hypotenuse, which is 30, and what is the adjacent segment? 6. All right, folks. How we doing? Is this okay for everybody? Yes? All right, let's get you some homework here.